All right, let's dive into one of the weirdest and honestly most important ideas in all of science. It's a concept that completely flipped our understanding of the universe on its head. The idea that energy doesn't flow smoothly, but comes in tiny, individual packets. So let's start with a little thought experiment. Just imagine for a second that energy isn't like a smooth, continuous river of water. Instead, what if it was more like a stream of tiny individual marbles? This one little shift in thinking is what absolutely shattered the old classical view of physics and kicked off the entire quantum revolution. To really get why this was such a big deal, we've got to rewind the clock a bit. Let's go back to the world of classical physics. This was a world that made sense. It was orderly. It was predictable. And for the most part, physicists thought they had it all figured out. But a huge, huge crack was about to appear in those perfect foundations. And this slide right here, this gets to the heart of the disagreement. On the left, you've got the classical view. It sees energy like a smooth ramp. You can stop at any point. You can have any amount of energy you want. But the new idea on the right is that energy is quantized. It's more like a set of stairs. You can be on step 1 or step 2, but there's no such thing as step 1.5. The crazy thing is, that classical model worked beautifully for big stuff, like planets moving through space or billiard balls bouncing around a table. But when physicists pointed their instruments at something as simple as the light glowing from a hot piece of metal, the classical rules didn't just bend, they broke completely. And this failure wasn't just some tiny little error. Oh no, it was a full-blown disaster, famously called the ultraviolet catastrophe. See, the old theories predicted that any hot object should be blasting out an infinite amount of high-frequency energy, like ultraviolet light. And that's just absurd. If it were true, lighting a campfire would basically vaporize the entire planet. Something was deeply, fundamentally wrong with the laws of physics as they knew them. And right when physics was in total chaos, this is where our hero enters the story. A crisis this big needed a solution that was just as big, and a physicist named Max Planck was about to deliver it. So picture this. It's the year 1900, the turn of a new century. Max Planck, in what he later called an act of desperation, took a wild leap of faith. He proposed an idea that even he thought was just plain weird, but it was the only thing that made the math work. And that single idea didn't just solve the problem. It fired the starting gun for the entire field of quantum mechanics. This was it. This was his revolutionary insight. He basically said, what if energy isn't exchanged smoothly? What if it can only be spit out or sucked up in these little prepackaged bundles? At first, he just thought it was a mathematical trick, a way to get the right answer. But it perfectly explained the experimental data that had left every other physicist totally stumped. He needed a name for these little energy bundles, so he called them quanta. But then he realized something even more profound. The amount of energy in each little packet wasn't random. Nope, it was directly tied to the frequency, or you could think of it as the color, of the light being emitted. And this simple observation gave us one of the most famous and powerful equations in all of physics, E equals hf. The energy E of a single packet, or quantum, is equal to its frequency, f, multiplied by this brand new, incredibly tiny number. A new fundamental constant of the universe, which we now call Planck's constant, or h. This simple little equation, well, it changed everything. Okay, so Planck's idea worked perfectly, but why? Why on earth would energy come in packets? It felt like a fix, a hack, not a fundamental law. The real reason wouldn't be fully understood for a few more years. And honestly, the answer was even weirder than the problem it was trying to solve. Because the secret, as it turns out, is that at the very smallest scales of our universe, everything, and I mean everything, including particles like electrons, doesn't just behave like a tiny ball. It also behaves like a wave. Okay, so here's how it all connects. Think of an electron inside an atom, but don't picture a little marble orbiting the nucleus. Instead, picture a wave that's trapped, confined inside that atom. Now, think about a guitar string. When you pluck it, it can only vibrate at specific frequencies, right? It creates specific notes. You can't get a note between C and C sharp. It's the same for that electron wave. Because it's trapped, it can only form specific, stable, standing wave patterns. And here's the absolute key. Each one of those allowed patterns corresponds to a very specific, discrete amount of energy. And that's it. That is why energy is quantized. It's just a natural result of waves being trapped in small spaces. Now let's be real, that is an incredible, almost unbelievable claim about how reality works. Saying that everything is secretly a wave, you'd better have some serious proof. So as you can imagine, scientists immediately went to work trying to test this idea. And the evidence they found, well, it was overwhelming.
Planck's original data on hot objects was just the start. Then, Einstein used the idea of quanta to perfectly explain something called the photoelectric effect, showing light itself can act like a particle. And you know the very specific, unique colors that different atoms give off when they're heated? That's their emission spectra, and it was perfect, undeniable proof of these discrete energy levels. One by one, experiment after experiment confirmed that this bizarre quantum world was the real world.
So you might be thinking, okay, tiny waves inside atoms, discrete energy levels, what does any of this have to do with me? Well, it turns out it has everything to do with you. This isn't just some abstract footnote in a physics textbook. It is, quite literally, the foundation of the modern world you're living in right now. Every single one of these technologies is only possible because we finally understood that energy is quantized. Lasers? They work by forcing electrons to jump between very specific energy levels and release a packet of light. The semiconductor chips in every computer and phone rely on our ability to precisely control these quantum states. Without quanta, there would be no digital age, period. So what's the most common, everyday piece of technology that runs on this mind-bending physics? Something you probably have with you right this second. Yep, your smartphone. Its processor, its camera sensor, its super bright screen, they are all absolute masterpieces of applied quantum engineering. It's a direct descendant of that strange, desperate idea Max Planck had over 100 years ago. It is, from top to bottom, powered by quanta. So think about that. Understanding this one fundamental, weird rule about the universe, that energy comes in packets, is what gave us the entire 20th century. It gave us computers, lasers, solar power, the internet, and that leaves us with one heck of a question. As our ability to see and control the quantum world gets even better, what will it build for us next?